Today we are going to discuss about the OFDM communication. So OFDM stands for Orthogonal Frequency Division Multiplexing. So what exactly is frequency division multiplexing and why orthogonal we are going to use, and how the process it is being executed in general communication, that we are going to see today in today's lecture. So as we know, we are in urge of to transmit higher data. So to transmit higher data rate, if we want to transmit higher data rate, suppose we will consider this as higher data rate. So in frequency division multiplexing, we are having multiple subcarriers which are orthogonal to each other. Those are placed. So this will give us the flexibility to transmit multiple subcarriers. So in FDM, that is frequency division multiplexing, due to the orthogonal signals, we are achieving the higher data rate and intersymbol interference. Also, we can avoid. So first of all, we need to understand that carrier. So suppose this is two-dimensional plot which we are having in and as per 3GPP there are these are the time domain symbols which is present, and these are the frequency domain subcarriers will be present. So initially the higher data whatever it is present, so those, if we have to transmit it further, so we need to divide it into the multiple subcarriers. So carrier means this is the frequency domain we are going to transmit the data, which is higher data. Higher data we are transmitting it into the multiple subcarriers with the narrow band sub datas are there, subcarriers we can say. So these subcarriers we are transmitting means we are processing it at the TX end. So this is the TX end processing. So here multiple, the higher data are divided into the multiple subcarriers, and each subcarrier is modulated with the QPSK or QAM, means quadrature phase shift keying, quadrature amplitude multiplexing modulation, means 256 QAM. Like that, different modulation schemes we can apply on the multiple subcarriers. So this is used for the higher data rate, and QPSK is used for the lower data rate. So these subcarriers, multiple subcarriers, we are transmitting over the air, not over the air. This is at the TX end. We are transmitting it. We are processing it. So these are converted into the, suppose this is serial to parallel conversion. We did it at the TX end. So after that we are doing subcarrier. Then we have to do because this is in frequency domain till now. These are subcarriers. So we have to convert it into the these multiple subcarriers we will take and we'll process it through the IFFT block, because this is in still it is in frequency domain. We are converting it into the time domain. So after converting into the time domain, these multiple subcarriers, again the CP removal will takes place, and after CP removal, no, here CP addition will be there. So after CP addition, we are converting this parallel data into the serial data, and it is getting transmitted over the air. So this is the transmitted in the time domain. The data whatever it will be present, that will get transmitted over the air in the time domain format. So these are the symbols which we transmitted from the TX end, or the samples, TX samples, those are transmitted over the air. So this is done at the TX end. So later on at the receiver end, when we'll receive the data, those data will be present in the symbol format. So this is as it is transmitted with the serial way, we need to again convert it into the parallel streams whichever it was present. So after that, these are subcarriers whatever we transmitted at TX end, those are demodulated at this end, which are modulated by QPSK 16 com and other 256 com, those will get demodulated. After demodulation of this, we need to remove the CP. Actually, initially CP removal will be there, and then we will do the demodulation of each subcarrier. And after doing this subcarrier demodulation, we need to do the FFT operation on this. So FFT operation on the symbols, if we do, so after doing it, it will get converted into the frequency domain. So as this is in frequency domain, so these are the subcarriers. So again symbols will get converted into the subcarrier domain. Subcarrier is nothing but the frequency, and then we will apply the FFT as we applied it over here. So this will get converted into the frequency domain. So after doing this process, at the end we need to do the here CP removal as we did it. Here we did the demodulation. Here we did the FFT process. So through that, after that, these parallel stream, whatever it was present, that will get converted into the parallel to serial conversion. Again we need to do, and at the end, whatever the data which we transmitted at the TX end, which is high data, which will get received at the receiver end. So this concept is similar to the prism, how the prism, which will consist of the multiple waveforms which we are transmitting with different colors, red, green, blue, yellow, orange, red, all those Vibgyor which will transmit to the prism. So at the end we'll receive it as an white waveform, or the white waveform when we'll transmit, it will get received at the other end by the inverse process in converted into the multiple waves which with the different frequencies. So similar concept it is being used in the IFFT and FFT process, and through that we will achieve the serial to parallel conversion and parallel to serial conversion, and through that we can achieve the higher data rate processing at the transmission through the OFDM signal. So by converting into the multiple subcarriers, the frequency selective fading means particular these subcarriers which are there. So if suppose we will consist higher frequency range which are impacted by the fading, so those will get nullified by converting into the multiple subcarrying. So frequency selective fading will get converted into the flat fading. So due to this we can have the fading effect get reduced and the flat fading will be there. And now as we see in earlier lectures that coherence bandwidth will be better, so that will give more gain, or the other issues related to the delay factor and Doppler will get reduced. So that's all. Thank you for today.